that's explanation for that. So this is the Hubble Space Telescope. And this is Edwin Hubble, smoking a rather long cigar. Edwin Hubble was who the telescope was named after. He was born in 1889 in Virginia and made his discoveries in the Mount Wilson Observatory in California using the Hubble Telescope. So this is some of his discoveries. This is a Cepheid variable star. It's a star that pulses at a very good brightness, specific, and you could use it to calculate distance. Now, in Edwin Hubble's time, it was thought that our galaxy was everything there was in the universe. They thought that nothing was outside of our galaxy. Hubble, however, used a telescope and these Cepheid variable stars in the Andromeda galaxy, which I know people who did the Big Greek language arts packet know the Andromeda constellation. So, using the Cepheid variable stars, he figured out that Andromeda was actually outside of our galaxy, meaning that our galaxy was not the only thing there was. And that completely blew everything out of the water, and it was shock and carnage and mayhem for a while. And this is the second discovery about the universe. So this little diagram here indicates redshift and blue shift. So essentially what it is you know light travels in waves from my previous thing. And so imagine if the light travels in waves, so imagine that you're staring at a light bulb and you could somehow see the waves. Now if the light bulb was moving away from you super fast, then the waves would stretch, and the longer the waves, the nearer it gets to the red end of the spectrum. They call it redshifted, as you can see here. The opposite happens when it's moving towards you. It's blue shifted. So this is significant because Hubble figured out that all the stars and galaxies were redshifted. However, the further away they were, the more dramatic the redshift, meaning that the universe was expanding faster and faster. This naturally led to the conclusion that everything's going apart, then it must have started when everything was together at a point. So in this way, Hubble thought of the beginning of the universe. And Einstein actually, in his equations, he introduced something called the cosmological constant, which would just hold the universe in place. He had thought of the universe expanding, but decided, nah, that's never going to happen. And of course, like 3 years later, Hubble figured out that the universe is indeed expanding, and Einstein was very annoyed and just called it his biggest blunder. Telescopes. This is Galileo. He was the one who first invented the telescope in 1610, 1620. And the reason it's a space-based telescope and not the telescope on the ground is because the atmosphere messes around with light. So this is why the stars twinkle. Like, imagine you're taking an eye test, except that you're taking the eye test from underneath a pool. But the water is going to move and shift and mess with your field of vision. This is what happens with stars. Like, you're going to have trouble seeing 20 feet from you, let alone have an eye chart underwater. So this is why you have to have a telescope in space, beyond the reach of the atmosphere, rather than just looking up with the atmosphere. Hubble invention. So, Hubble was Hubble was first devised in the 1950s, I think, and so it was just a groundbreaking project. It cost billions of dollars, and normally it would use a mirror to collect the light and bring it down to a single point, so where we could receive images. But the telescope would have to be like several miles long, using regular mirrors to get to a certain point. So they ended up using double mirrors. Like, they'd have a mirror here collecting the light, then just basically bounce back and focus between two mirrors to get to a point where we could actually see stuff. These mirrors were the finest mirrors are the smoothest things that we have ever created. If any part of the mirror deviated from a perfect curve by less than a 50th of an inch, the entire project would have to be scrapped. So that's how precise it was. Which of course leads to our next Hubble imperfection. And so what happened was the people doing it noticed, the people polishing the mirrors noticed that they had a tiny deviation. But of course they're like, who cares? We're being paid billions of dollars for this. Let's just not tell them. Brilliant idea. So they sent it up into space. Everybody was really excited. There was the clearest images ever in the history of mankind. And when they finally got the first images, it was all blurry and wavy. Like they'd literally be better off using a spyglass looking up at the sky. So what happened was the guys who polished the mirror had polished it 1/50th the width of a human hair too thin, and that width completely screwed up the entire telescope and made everything all blurry. So I've talked with Miss Madich and Mr. Subtle, and both of them remember the times of I think it was 1999 when there was a whole bunch of cartoons and disdain that NASA had spent billions of dollars on this telescope and it didn't even work. Fixing the problem. So the problem was that the mirror was all kinds of screwed up. So meaning that the light was coming to a focus at different points. So the way one guy figuring it out, he after like a long day of press conference, he went home to take a shower, and then he realized he had one of those extendable shower heads, like he put out that flip thing up. He's like, light bulb, I have an idea. So so like basically they would get an instrument, they would in space would sort of extend it, and then flip it out tiny mirrors that would correct all the focus points at the same time. And as you imagine doing this in space with a bulky spacesuit on, and you only get one chance. Otherwise, a multi-billion-dollar project just goes out the window, space junk. And this was eventually happened, and I can't really remember when it happened, but I do know there's been movies about it. Results, A+. So the results of this was we got some of the clearest images of all time. So it has helped figure out stuff like quasars. Does anybody know what quasars are?
No.
Honestly, I didn't really expect much of anybody to answer. However, I do know, like, those of you who were in band in 5th grade, there was a song called Quasars, if you remember.
Yes.
So quasars are basically these like giant bubble things at limits of our perception. And what they actually are black holes in the center of enormous galaxies. Now black holes don't completely eat everything. Like they eat something and just blast out X-rays, radiation everywhere. So these are giant black holes feeding on enormous amounts of stuff and sending X-rays and radiation everywhere. So, and as deep field. This is the fun part. So what NASA did was they took a random area of the night sky and studied it for weeks. This was the area of the night sky you would get if you took a drinking straw and looked at the night sky through the drinking straw. And they studied that one area for weeks, and they found 10,000 galaxies in that area. See, every single speck of light, this entire square, is a galaxy, each containing hundreds of billions of stars, and possibly life. Seen back in time. This is the interesting part. So, what happened? Did you know that every time you looked at the sun, you're not seeing the sun as it is, but as it was 8 minutes ago? I think it's like 8 minutes and 22 seconds or something. The reason is because light, it moves very, 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 very fast, but it moves. So that means light takes time to move, which means that if we look at, for example, the quasars, then we're looking back in time like ago or something. However, this does not mean I could just take a telescope, look and see a T-Rex right in this middle of this room. However cool that would be, I can't do that. It has to be far away enough so that the light takes time to reach us. Clearest images ever. So has the clearest images ever. So those leaps of 10, leaps of a factor of 10. The first leap was when Galileo took the telescope up to his eye, and this was the second leap in a factor of 10. This thing was 10 times, this was a factor of 10 more powerful than Galileo's telescope. And here's a montage of images. Honestly, I really have no idea what this is. I think it's a nebula. It was kind of like 10 o'clock in the tennis. These are the pillars of creation. These are giant gas clouds that form stars. And they have found evidence that this thing was destroyed on like 7,000 years ago by a supernova. And seeing as this is 6,000 light years away, we have about 1,000 years to see it before it just goes out. Yep.
On that last image, so that's a picture that we've received from the Hubble.
Yep.
And that's a picture from thousands of years ago.
Yep.
It's traveled
like
that far.
7,000 years ago or something.
So just try to wrap yourself around that, ladies and gentlemen. Because
So
it's traveled, that's how far away it is.
Is this a Barrow galaxy? Those of you who were here at Cinco de Mayo will know my sombrero. This is aptly named the Barrow galaxy, and I think at the center that's probably a black hole. Sending out radiation. This is supposedly the clearest image of a star we've taken. This is a single star. Whoops. This is probably the best one this is my personal favorite. It's the Eye Nebula, I think. And this is my actual, this is the actual coloring. So that's very cool. This is the Ant Nebula. And it has nice shades of purple, which is interesting.
Also looks like an hourglass.
Yeah, it does kind of look like an hourglass.
Ladies and gentlemen, if you have a question, raise your hand.
Okay, anyway, this next line's for humoristic effect. Okay, so the reason I put this slide on here is because I kind of want you to grasp how amazing the Hubble Space Telescope is. And like Mr. Sutton says, the conclusion should be why do we care? And the reason we should care is because we are receiving the clearest images ever. Also because Hubble has helped determine the age of the universe, which is interesting. So I've already told you about redshift and stuff like that. Now if you look far enough, you'll eventually see into the distant past. Not eventually, you will see into the distant past. And it's helped determine the age of the universe, which I think last time I